I'm Dr. Gordon Hamilton, talking from Masters Academy and College. This is the third lecture entitled Survivor Climate Change Planet Earth. Last time we were talking about ice cores. There's two places that ice cores are drilled. There's Greenland, and here's a sample of some ice cores being drilled in Greenland. Ice cores are drilled in the Antarctic and in Greenland. Ice cores are generally about 3 kilometers thick. So the Greenland ice cores, they are good up to about 120,000 years ago. And the Antarctic ones are good beyond 400,000 years. So we can drill down. There's less precipitation each year in Antarctic, so even though it's 3 kilometers deep, the same as in Greenland, you get a different information. So here's Vostok, coincidentally, and there's a nice place to maybe go for a honeymoon. And here are some ice cores right there in Vostok. So what else can we use from these ice cores? Carbon dioxide is one thing that we can pick up. We can see little bubbles in the ice core. And so here's the ice core. We can see little bubbles in there. And we can blow them up and we can look inside. And what do we get? Well, we get samples from the atmosphere long, long ago. So here's some nitrogen, some oxygen, and there's carbon dioxide. Well, there we have carbon dioxide. And what we're going to do is we're going to see that carbon dioxide is a global warming gas. So we're going to hit this thing with some heat. We're going to hit it with infrared light. Here we go. Zap. And there's different ways that carbon dioxide could react to that. But it's not an asymmetric stretch. These are different ways that the molecule can vibrate. It's not that. It's not the asymmetric stretch. It's not the symmetric stretch. The way that carbon dioxide reacts whenever it's hit by infrared light is to start bending like this. And the effect of that is to, instead of letting the infrared light escape from Earth, the carbon dioxide absorbs it and keeps it in the atmosphere. And that's why it's a greenhouse gas. So remember this from NASA, this image. Remember that the clouds here were keeping in light. They were acting as a blanket. Well, the same would be true for carbon dioxide. Carbon dioxide could be distributed throughout the whole atmosphere, and this might be the result. There we go. You notice that the satellite now is not seeing as warm. Yellow is not as warm as red. So, for example, in the oceans there, the satellite is not seeing as warm, and that's because there's a blanket protecting the satellite, protecting the infrared from escaping Earth. So the Earth would be heating up in this scenario. Now that's an extreme scenario. This is not a real image. This is just one I concocted for you guys. So what happens whenever we take that ice core data and we look at the bubbles all the way through over the last 400,000 years? What do we see for carbon dioxide? Well, the carbon dioxide ranges from 0.01% to 0.03% of the gas that we see in those bubbles. And here is the graph. Notice anything similar to that? Well, let's look at the temperature profile. Notice how closely those two are matched. Now we know that carbon dioxide is a greenhouse gas. That is not in contention. So what we want to see is, you can see here, whenever carbon dioxide levels increase, you notice that the temperature increases. There's nothing wrong with that, except that we see here in the last 100 years, we see our carbon dioxide going through the roof. This is why there was so much concern about global warming is because you look at that and you say, well, what happens whenever we go down here? Well, we're expecting, if carbon dioxide is a global warming, that the temperature is going to shoot up in Earth, like it has done in the past. So this is probably one of the most important graphs of the last 10 years. I can't think of a more important graph. This galvanized world leaders to go out and try to solve the global warming problem. However, since that happened, there has been more resolution brought to this graph. And first of all, let me just show you about the carbon dioxide content. So the top graph, that is the carbon dioxide level over the last 40 years. So you can see how fast it's increasing. Okay? Over the last whole 40 years, we're above at any time over the last 400,000 years. Every year, we're breaking new records for carbon dioxide content in the atmosphere. Okay, so just look at those two graphs. Okay. But within the last few years, we've had more information about this graph. And it's a cause and effect relationship. So, I'm going to just exaggerate this a little bit. So I'm going to move over this graph a little bit. And I'm going to highlight the carbon dioxide increasing. And then I'm going to highlight the places that the temperature increases. So if we saw this, we would say, well, it's pretty clear that whenever carbon dioxide increases, that might be causing the increase in temperature because it comes first. The opposite alternative is we can move it the other way, and then we can see that the global temperature goes up, and then there's an increase in carbon dioxide. So which of these is true? Well, whenever this graph first came out, nobody knew, but people thought that they had to take action. It turns out that this is the true scenario. First, the Earth is warming, and then the carbon dioxide levels increase. So, no time in this last 400,000 years does it appear that carbon dioxide was the trigger for global warming. So now we've got conflicting views. Now we have world leaders going down this path of changing carbon dioxide emissions, and yet their motivation in this graph is a little bit weaker than when they started. Okay. So, I admit that I lied last time that I talked to you, and I lied with one crucial respect with this ice core. And that is that way down here in the bottom, things are very badly messed up, and we can actually not tell the dates like we can in tree rings by counting back. We can actually only do that for Greenland, and only for the last 10,000 years. How do we get the date for going back 400,000 years? We cannot get it in any easy way. This is a very, very tough problem.